looking at the simple calculator example, simple calculator, and we got to the point where we were going to look at how the button works. And that's where we're gonna first do a very quick review of the stuff that we saw before. Then we are going to get into how the button works. Because again, that is a little different than stuff that you may have seen in other programming languages. Alright, of course we have the Android manifest file. That is the file that contains information about the application used largely for the installation of the application. It will contain things such as, the name of the activity and some information about launching the application. It also contains permissions, which this application doesn't really have any explicit permissions. But for example, if it were to go out and access the internet, all right, you have to let people know about that. If you think about it, this provides a good assurance to users because number one, people pay for their internet connection based on how much they download. Some people have unlimited, but most people have a certain amount. So if your application is running out and grabbing stuff from the internet, you better let folks know that before you install it, before you use up all their bandwidth. All right, so permissions go in there as well. We have a main XML, which is a screen layout. In our resources folder and in the layout folder, we have the main XML. We have the values, which contains any of our hard-coded strings. We have the drawables, which are the images, and again, we have different versions of them to correspond to different screen densities. And again, I'll probably say this a million times because this is the one thing my last class had issue with, and in fact I had issue with when I first learned this. This doesn't relate to screen size, it relates to screen density. Okay, so it's the density of the pixels that when we talk about like the HD PI folder. That is for high density pixels. So it doesn't matter how big the screen is, it matters how dense the screen is. And again, because there are more pixels in a given area, all right, the pixels are closer together essentially. To make an image appear the same on a high density as compared to a medium or low density, you need a bigger image. Because 100 pixels that are spaced close together is going to take up less space than 100 pixels that are spread far apart. Okay. We left off looking at our Java source files, and we have two of them. We have two classes. I think it's important right off the bat to talk about separating the user interface and sort of the control function from the business logic or the organizational logic. The pattern for that, and I'm not saying this strictly fits that pattern, but it pretty closely fits the pattern of MVC. Has anyone heard of MVC? Model, View, Controller. All right. Model is your business logic, is your organization's logic. It's a model of some real-world activity. View is the user interface, what the user views. And finally, control is sort of a boss that sort of runs the show and hooks everything together. All right? Just like in the real world, the boss might not do the actual work, but the boss, at least a good boss, is going to be responsible for coordinating stuff and making sure that different areas are talking to each other and are connected together, and that supports them doing their functions. So this examples activity Java is sort of the controller for here. It's sort of the running the show. To review what we have so far, all right, this is an activity. It extends activity. All right. OnCreate is what happens when this activity initializes, when it starts. We call super OnCreate. In other words, we're calling the super classes OnCreate function, all right, which you will do typically with this. Then we're setting the content view. And what that is that's essentially setting the screen associated with this activity. And where do we get that screen? We get it from the main XML file. So when we do this, essentially we're bringing to life that XML file. That XML file specifies a certain layout. When we say set content view R layout main, we're sort of like inflating it. All right? And later on in the class, we'll even hear of, there's a function, I believe, a method called inflate, which again takes sort of the description of the layout and actually makes the real objects. So when we set that content view, we essentially take this main XML and start actually creating those objects. So let's pull up the main XML real quick. All right, if you notice, we have a linear layout, which means, again, they're simply one after another. We have a text view object. We have an edit text object, a spinner object, a button object, and a text view. You know, sitting in the XML file, that's just a description of some objects. It's saying, hey, we're going to create some objects. And in fact, these are the properties we want those objects to have. This is just another way of setting the properties, right? You can have set and get methods on classes. By putting it in the XML attributes associated with that object, that's saying, hey, I'm going to create an edit text view, and oh yes, by the way, the ID is going to be this. The layout width is going to be 100 dp. The layout height is going to be wrap content. In other words, make it as big as it needs to be. And then finally, the input type is number. Those are all attributes on the edit text class. And we're setting them for this object. So this is sort of a description of the objects that we're going to create when we do this. And set the content view. All right. So those objects are sitting out there. There's a button object sitting out there. There is some text view objects sitting out there. There's a spinner object sitting out there. There's a button object sitting out there. All those objects are sitting out there, all right, in the heap, in the Java Virtual Machines heap. The problem is we don't know how to access them. We don't know how to refer to them. We don't have a reference to those objects. We don't have a pointer to those objects. All right? I don't know how much they go into this in C# about what an object reference variable is, what a pointer is. But when you create an object, you're creating it in a certain section of memory called the heap. All right? What you actually store in the variable is a pointer to where that object lives. So you effectively store an address to it. So that object can be out there. We need a variable to point to that object, though. And that's exactly what these statements do here. And we talked about those, or I'm sorry, this one statement. We talked about this in a little bit of detail. Button calc equals button find view by ID, RID calc. What this is doing is, this is a method that exists on any view. All right? Or associated with any activity. We're finding the view associated with the activity that has this ID. And we're saying, I want to treat it like a button. All right? And I want to store a pointer to that object in the variable called calc. So, button calc defines a variable. That is, defines a object reference variable. An object reference variable points to an object. All right? And in this case, we want it to point to a button object. So, we say, all right, I have an object reference variable called calc. It's going to point to a button object. What button object is it going to point to? Find the one on the page, or on the screen, on the view, that has this ID, and oh yeah, we're going to treat it like a button. We have to treat it like a button because we declared it to be a button. Now, we know that it's a button, so everything's going to work out okay. If it turned out we were wrong, and someone went in and edited that and made that ID be an ID for a text view or something, our application will blow up. All right? Because we're saying treat it like a text view when actually it's a button. All right? So now we have a pointer to that button object that's sitting out on the heap that got inflated when we set the content view to that XML file. So now we have a pointer to it. Now we can do stuff to them. We're going to use the same kind of thinking in a minute here to pull the text box and the labels and all that sort of thing. All right. This is a little bit hard to understand. This is where you have to be really good at your parentheses and curly brackets and so on. This is where, again, you know, I'll stand in front of the camera. Take a good look at me. I am not a neat person, all right? But if you notice the code, all right, which I kind of changes code from an example, but still, this code, the indenting is very neat because you will go crazy with a statement like this if you don't indent it properly, all right? Let's look at what this statement is. The statement starts off by saying calc. What is calc? Well, calc is our object reference variable that points to that button. All right? So we're doing something with that button that we just got a pointer to. What are we doing? We're setting an Onclicklistener. Specifically, we're calling a method that says set Onclicklistener. All right? A method or function, in all cases, does what? It takes arguments and does something with it. What does this function do? What does set Onclicklistener do? Well, it says, it defines the code that is going to handle when that button gets clicked. All right? So when that button gets clicked, this is the code that's going to handle it. Now, Java, just like C# being a strongly typed language, you have to specify your arguments as being a certain type. All right? If you've done JavaScript programming, for example, you don't have to worry about that. You just create a function and say it's going to accept an argument. And JavaScript essentially figures out what kind of argument it is. That's not the case in Java. In Java, the language is strongly typed, which means that you have to specify the type of your argument. What is the type of this argument? And the nice thing is if we hover on it, oops. Every time it starts to show up, I get impatient and click it. The argument that this set Onclicklistener is expecting is an Onclicklistener object. Okay? Makes sense, right? You know, that's what that is. So what is that? That's an object that we're going to create. Now I can create that object a couple of different ways. But here, I'm actually creating that object sort of on the fly. All right? I'm sort of doing it on the fly. I'm doing it this way because this is a chunk of code that's going to be specifically related to this button in this view. All right? In other words, this isn't reusable code. All right? This isn't code that I'm going to worry about reusing. This is really what I like to call sort of the glue code. The code that sort of glues, or the controller code, that glues or ties together that user interface button, that is, or user interface element, that is the button, with the business logic. So I'm not going to reuse this, right? This is the behavior I want for this specific button on this specific screen. Therefore, I don't need to create a custom class for this. I certainly could. I could define a class, all right, of, you know, calculate button Onclicklistener handler. I could create that class. And then I could create one of those. But there's no need to do this. This is sometimes called an anonymous class or an anonymous object because I don't really have a pointer to it. It's not really a class that I can instantiate. I'm making one right here, and there you go. All right? So, this function, and again, it's important to understand that all this line, all this code, from here to here, this is, whoops, actually going even further. From here to here, all of that is the argument to the set Onclicklistener. All right, that whole chunk of code that's highlighted is the argument to that listener. Now, how do I know that? I know that because I was good about the indenting. And I can see that this bracket goes with, or parenthesis rather, goes with this parenthesis. So everything between there is defining the object that's going to handle the click. So normally we would give this function once, an Onclicklistener object, which is an object that's built to handle buttons being clicked. All right? But we're just going to declare one on the fly. We don't have a class file for our tip calculator button. We're just going to just make a click listener object on the fly. So that's what new view Onclicklistener means. All right? I'm going to make a new object of type Onclicklistener, and that's going to be my argument. That's what I'm going to give to that button to be the object that's going to handle when that button gets clicked. All right? Again, notice that we look at our imports up here. We imported view, so we don't have to put the full package name for view. We can just say view. But we didn't import on Onclicklistener, so we have to say view.Onclicklistener. All right? We imported the view package, but again, we have to do this to create the Onclicklistener view object, or object. So, this is our argument. All right? This is the argument to the set Onclicklistener. The set Onclicklistener needs an Onclicklistener object. This is, all this code is creating that object and associating it with that button. Okay? So, from here to here is the code that actually defines the object that we're going to use. We're not using a pre-written Onclicklistener that's sitting out there. Why? We don't need to make a pre-written class for this. We can just create the class on the fly. All right? So there's no need for us to create a Onclicklistener class and have it sitting out there. We can just create one on the fly. But we have to specify what's in that Onclicklistener. Well, what do you think an Onclicklistener needs to be able to do? It needs to be able to handle on-click events. Right? Kind of self-evident, right? So, what we have to do is we have to associate with that object. We have to define for that object what to do when the user, when a click occurs. All right? And that's what we do right here. We define what gets done when this click listener notices that its button has gotten clicked. All right? And so we define this method that's accepting a view, the view being who got clicked. All right? We then go in and do our thing, do our actual calculation. And that consists of, number one, creating a new MEO object. All right? If you remember back from last week, this was a tip calculator. So our tip calculator, we accept the amount of the meal and the level of service, whether it be excellent, average, or poor. All right? So we create that meal object to do the calculation. Now, I could have put this calculation in here, in this button. But a meal is something that I might want to reuse. Okay? So there's a difference between this code and the code for the meal. The meal I could reuse. I could have all kinds of functions associated with the meal. Calculate the calories, calculate, how much protein was it. Any number of different things I could have as attributes and methods associated with the meal. The only thing that's relevant in this example is the amount of the meal and the tip. All right? But I could have a lot of other ones as well. All right? So therefore, the code that does the tip calculation, I'm going to put in its own class. And again, the advantage of that is I can use that class anywhere where I need to do something with meals. And the advantage then is if I need to change something about the way that that's calculated, I only need to change it in one place. So I think it's important to understand why this code is tied up in this object, yet the code that does the actual calculation isn't. All right? It's important to understand that. And the reason is it's a matter of reusability. This code is really just code that's going to glue together my business logic and my UI. It's the controller code. The code that actually does the calculation of the tip, well, that's my business logic. That's my organization logic. That's my problem domain logic. That's my model of the real world. And that I want to be in its own class so I can reuse it and expand upon it and so on. So, I create my new meal. Just like I got pointers, or a pointer to the button up here, I'm getting a pointer to the three different things on the user interface that are relevant to the calculation of the tip. That is the text that contains the amount of the tip, the text that contains where I'm going to put the answer, where I'm going to put the results, and finally, the spinner control that allows me to select the level of service, whether it be average, medium, or poor. I then set a couple properties in the class, all right, or in the object. So I define for my object what the cost of the meal is and what the level of service is. Here I define the cost. Here I define the level of service. Then I go and I calculate the tip by calling the calc tip function on that object. So for that meal, what's the tip? And that method call will take the cost that I set and the quality of service that I set, and will do its thing, and it'll come up with the answer, and it'll take that answer then and stuff it into the text box for the results. All this is the code that's going to execute when the button gets pressed. All right? I can't stress this code enough. There's a real good chance that I'll ask questions about this on the quiz, right? Because it's really important to understand what's going on here from, it'll help you with your Java programming and just in terms of the Android framework, what we're doing. All right? Number one, we're defining a listener. All right? Now in C#, I don't think they use the word listener, do they? They would say like event handler or something like that. All right? But the idea is the same. It's the code that's going to go and it's going to run when something happens. All right? So in C#, the thought is that it's handling an event. User clicks on the button, That's an event. I'm going to handle it. The terminology is a little bit different here. It's a listener. And if you think of it, it's a class that sits out there listening or waiting to detect some event happening. And then when it happens, it goes and does something. So, in a nutshell, this line sets the event handler for that button. All right? What does it set it to? It sets it to a new object that it's creating on the fly. What is that object comprised of? It is comprised of the Onclick method, which is obviously what you need if you're going to process a click handler or create a click handler. That goes and pulls values from the view, does its calculation, and puts the results in the text box. Now, because of the way I declared that inside of the bigger class, it knows about the view and all that, so I don't have to pass those as arguments. That's another sort of advantage of doing it this way. So very important code, all of this. The parts are important. These two lines are pretty standard. You are likely going to have, in all of your applications, lines that point to elements in your user interface or create pointers to them, which is what we do with that button calc. And then we're also likely to, in all our applications, set some sort of listener to specify, hey, when something happens, this is what I want to have happen. Questions about this? All right. Let's look at the meals object. Now, here's the nice thing. All right. Here's the nice thing. Let's say, for example, that we already had a meals object, that someone developed it. All right. And your job was to create this mobile calculator, all right, to calculate the tip. All right. You could create all this without even looking at the meals object, other than to know what methods you need to call. All right. The whole idea of creating these objects, especially the model, the business model, the business logic, is to have a little component that we can plug in to our code wherever we need something of that type. So whenever we need a meal, I can use a meal object, and I can just pop that into my code like a component. I don't have to create something custom for my application. It's kind of like components on computer hardware, right? As long as I have the right kind of plug-in, I can plug any mouse into this, as long as it has the right plug on the other end, So it's a component. I don't have to use this mouse or some kind of special mouse. If it has a little USB connector, I can connect it up to this, and it will work fine. All right? I don't have to do something special. All right? So let's look at this meal component. Now, this might be a little different than you've done in C#, the way it was taught in C#. I'm not sure how it's taught in C#. But the one thing that you will notice with this is that the attributes for this class, of which there are two, cost and level of service. Cost is a double. Level of service is an integer. All right. 0 for poor service, 1 for average, 2 for excellent service. We could do things with an enumeration or whatever, but we didn't in this case. Those are defined as private. The methods are defined as public. Now,